Assalamualaikum and hi everyone. In this lesson, you are going to study what is bond polarity and dipole moment, and also we will see on how to deduce the polarity of molecules based on the molecular shapes and the resultant dipole moment. So from the values of the resultant dipole moment and the molecular shapes or molecular geometry untuk sesuatu molekul, we will be able to identify polarity of molecule. Okay, kepolaran untuk sesuatu molecules. So for part A and B, we will cover in this lecture, and for part B, especially for the examples, you will see more in your tutorial class. Before we study more on the polarity of the molecule, let's see these two observations. What will you observe when we add oil into water? And how about the additions of alcohol into water? So from this observation, you can see that additions of oil into water will give you two layers of solution. This is called heterogeneous solution. So from here, you can see that oil is insoluble in water. Minyak tidak larut di dalam air. But the additions of alcohol into water will give you this homogeneous solution. So here you can see that alcohol is soluble in water. So to explain this observation, maka we need to study the polarity of the molecules. Because by knowing the polarity of the molecules, we can also identify other physical properties such as melting point, boiling point, and of course, the solubility of the molecule in other solution. So, to answer these two observations, maka kita akan study polarity of molecules in this lesson. So, to explain what we have just now, water is a polar molecule, but oil is nonpolar molecule. So, nonpolar molecule cannot soluble in polar molecule. So, hence, you will see two layers of solution after you add oil into water. So, nonpolar tak boleh larut dalam polar. But, alcohol is a polar molecule. So, polar molecule can soluble in another polar molecule. So, bila polar bertemu dengan polar, so that is the reason kenapa you nampak alcohol and water is soluble in each other just now. So, by knowing the polarity of the molecules of water, oil, and alcohol, we can predict their solubility when we add one molecule into the others. Bond polarity refers to a bond between atoms of different electronegativities in which the distribution of the density of the bonding electron pair is asymmetrical. Asymmetrical adalah unsymmetrical. Okay, tidak simetri. So, bond polarity will arise in a molecule di mana covalent bondingnya mempunyai atoms yang berbeza electronegativity. So, apabila terdapat atom yang mempunyai electronegativity yang berbeza, maka akan wujudlah unequal distribution of the bonding electron. So, unequal distribution of the density of the bonding electron ini, okay, kita gunakan terms asymmetrical, not symmetry. So, let's say we have hydrogen molecule here. So, this molecule terdiri daripada dua hydrogen atoms yang covalently bonded. So, from here, we can see that since these two atoms adalah atom yang sama, symmetrical atom. So, maka this bonding electron, distribution of the bonding electron here adalah symmetrical. Okay, kerana hydrogen and hydrogen ini mempunyai electronegativity yang sama. So, in this case, apabila distribution of the bonding electron density adalah symmetrical, this bond adalah non-polar bonding. In HF molecule, in this molecule, it consists of hydrogen and fluorine atom. So here we have two different atoms with different electronegativities value. So apabila satu bonding ni terdiri daripada dua atom yang berbeza electronegativity, so distribution of the bonding electron density is unsymmetrical ataupun asymmetrical. So in this case, this bonding akan menjadi polar bonding. So this molecule has bond polarity, and in this molecule it does not has bond polarity. Kerana bonding ini adalah non-polar and this bonding adalah polar. Bond polarity is divided into two categories. Yang pertama adalah non-polar covalent bond. So let's take hydrogen molecule as the example. So non-polar covalent bond will exist apabila kita ada dua atoms of same element in a covalent bonding. Okay? Sama seperti hydrogen molecule over here. So this molecule terbentuk daripada dua atoms yang sama. Okay? Yang terikat melalui single covalent bonding over here. And these two atoms will have similar electronegativity. Of course lah, kerana mereka terdiri daripada atom ataupun elemen yang sama. So, distribution of the bonding electron density between these two atoms in this covalent bonding is said to be symmetrical. Memandangkan dua atoms yang membentuk molekul ini adalah terdiri daripada atom yang sama, maka distribution of the bonding electron di sini adalah symmetrical. Okay, this is because these two atoms having similar electronegativity. The second one is polar covalent bond. So to discuss polar covalent bond, let's take HF molecule as the example. So polar covalent bond will exist when we have two atoms of different elements, okay, that connected by this covalent bonding. So dalam HF kita ada dua atoms yang berbeza. Okay, and they are connected by this single covalent bonding. So since they are different atoms and different elements, of course, they will have different electronegativity value. So between H and F, F is more electronegative than the hydrogen. So apabila ada perbezaan electronegativity di antara hydrogen dan juga fluorine yang terikat pada satu covalent bonding yang sama, maka kita boleh kata bahawa distribution of the bonding electron density between these two atoms is unsymmetrical ataupun termsnya adalah asymmetrical. Okay, so bagaimana boleh wujud asymmetrical distribution of bonding electron density adalah apabila dalam satu covalent bonding ini mempunyai dua atoms yang berbeza electronegativity value. So apabila wujudnya perbezaan electronegativity value di antara dua atoms yang terikat pada satu covalent bonding yang sama, maka distribution of the bonding electron density will be asymmetrical ataupun unsymmetry. So oleh itu, kita boleh labelkan simbol delta negatif untuk the most electronegative element dan delta plus pada kurang electronegative element. Okay, untuk less electronegative element. So here you can label delta plus here and also delta negative, okay, on the fluorine. So di sini we can see that since these two hydrogen mempunyai similar electronegativity, maka distribution of the bonding electrons here will be symmetrical. So this bonding is known as non-polar bonding. So apabila kita ada non-polar bonding dalam molekul ini dan ini adalah the only bonding yang ada di dalam sesuatu molekul, maka hydrogen molecule will be non-polar molecule. Kenapa non-polar molecule? Kerana satu-satunya bonding yang ada di dalam molekul ini adalah non-polar bonding. But in HF, since kita ada different electronegativities between these two atoms, so this will make this covalent bonding sebagai polar bonding. Okay, polar bond. So in this case, Apabila bond ini adalah polar, so HF is known as polar molecule. So ingat, konsepnya adalah untuk nak identify bond polarity sama ada secara non-polar covalent bond ataupun polar covalent bond, you have to study the two atoms that is directly connected by the single covalent bond. Jika ada perbezaan elektronegativity di antara dua atom yang terikat pada covalent bonding yang sama, maka akan wujudlah unequal distribution of the bonding electron density, and you boleh labelkan sebagai delta plus and delta minus. So from there you can identify this bonding sebagai polar bonding. Dan apabila bonding ini adalah satu-satunya bonding yang ada dalam this molecule, we can also make conclusion bahawa this molecule adalah polar molecule. Dan untuk hydrogen atom over here, since these two atoms adalah atoms yang sama, maka we cannot simply label delta plus and delta minus, okay, on these two atoms. Kerana apa? Kerana mereka mempunyai electronegativity yang sama. So, distribution of the bonding electrons here pun will be sama. How to show bond polarity in covalent bonding? So here we have HCl molecule between hydrogen and Cl. H is less electronegative than the chlorine, so hence we can put symbol delta plus on the hydrogen and delta minus on the chlorine. So since we have two different electronegativity atoms in this molecule, so this bonding is said to be polar. So to show the polarity of the bonding, okay, dalam bentuk lukisan, maka kita boleh gunakan this kind of arrow, and this arrow is called dipole arrow, di mana the cross end here showing less electronegative atom, and the head end over here showing most electronegative atom. So apabila ada sahaja perbezaan electronegativity antara dua atom sebegini, bond ini akan menjadi polar bonding. So we can symbolize this polar bonding dengan menggunakan this kind of arrow. So arrow will always pointing to the most electronegative atom, and the separation of charge here is called polarization, and bond dipole exists. Bond dipole ataupun bond polar lah, bond polarity exists. So here HCl has polar bonding, so the whole molecule will be polar molecule. HF is a polar molecule because the only bonding here adalah polar. So bila bond ini adalah polar, maka the whole molecule ini akan menjadi polar. Tapi, how if we have a molecule yang mempunyai lebih daripada satu covalent bonding like this? So, bagaimanakah kita nak mengetahui tentang polarity of the molecule? So, jawapannya adalah dengan melihat kepada dipole moment. Okay, dengan mengkaji dipole moment ataupun resultant dipole moment. So, by knowing the resultant dipole moment, we can identify polarity untuk sesuatu molecule. So here we have examples of hydrogen halides with their respective dipole moment value. So HF has the highest dipole moment value. Ini adalah kerana fluorine adalah lebih electronegative than the others. So the separation of charge between these two will be higher, and that will make this bonding lebih polar, dan itu akan menyebabkan HF molecule adalah lebih polar. So by referring to this value, kita boleh identify bahawa HF molecule has the highest dipole moment, and this shows HF sebagai the most polar molecule. So untuk identify polarity untuk sesuatu molecule, we will refer to the value of mu, iaitu dipole moment ataupun resultant dipole moment. So to get the value of mu, mu equals to Q times R, where Q is the charge in coulomb, dan R is the distance between charge. So in your level, value of mu yang kita akan kaji hanyalah dua value sahaja. Yang pertama, mu not equals to 0. So apabila mu not equals to 0, maka that molecule will be polar molecule. So oleh itu kita akan katakan bahawa that molecule has resultant dipole moment. Kenapa has resultant dipole moment? Kerana nilai mu-nya tak sama dengan kosong. So dia ada nilai resultant dipole moment. Tapi berapakah nilai resultant dipole moment tu? Kita tak perlu tahu. You don't have to identify in this level lah. Okay, so you just have to put mu not equals to 0. And then the other value of mu, of course, mu equals to 0. So when mu equals to 0, so that molecule will be non-polar molecule. And it is said that the molecule does not has resultant dipole moment. So bila molecule tak ada resultant dipole moment, mu equals to 0, so the molecule will be classified as non-polar molecules. So our discussion later on adalah berkenaan bagaimana nak identify molekul itu sebagai mempunyai mu not equals to 0 ataupun mu equals to 0. So from these two values, you akan identify the polarity of the molecule sebagai non-polar ataupun polar. Characteristic of a nonpolar molecule. A molecule is nonpolar mu0 if does not contain polar bond. For example, in this Br2, okay, this molecule is formed daripada combination of two same atoms. Okay, and they are connected by the single covalent bonding. So since atoms ini adalah sama, maka there will be no difference in electronegativity between them. So this bond is said to have no bond dipole. Okay, tiada bond dipole. So bond ini adalah non-polar bonding. So the resultant dipole moment of this molecule adalah 0. So mu equals to 0. Ini menunjukkan bahawa this molecule adalah non-polar molecule. So the other example will be F2, H2, Cl2. Any diatomic molecule yang terdiri daripada atoms yang sama will be non-polar. And the other one is shape is symmetrical and having same terminal atoms. Apa maksudnya shape is symmetrical? This is actually refers to basic shapes ataupun basic geometry with same terminal atoms. So you have learned a few basic shapes before this, AB2, AB3, AB4, AB5 and AB6. So those are basic shapes. For the basic shapes with same terminal atoms, the molecule also adalah non-polar. Okay, kenapa? Kerana walaupun dalam molekul tersebut bondingnya adalah polar, okay, tetapi all bond dipole can be cancelled with each other. So later akan menjadikan resultant dipole moment mu equals to 0. So let's take BCl3 as the example here. So BCl3 antara B dengan Cl, Cl is more electronegative. So you can draw this bond dipole. So di sini walaupun this molecule has bond dipole, so this bond dipole can be cancelled with each other. Kita boleh cancel fully ke semua bond dipole. Dan apabila kita boleh cancel ke semua bond dipole, maka mu will be 0. Okay, and the same thing goes to CH4 as well dalam methane. So antara C dengan H, okay, the bond dipole, the arrow of dipole akan masuk ke arah dalam kerana C is more electronegative than the hydrogen. So in this case, memandangkan CH4 ini adalah bentuknya tetrahedral, which is basic shape, and all terminal atoms adalah sama. So walaupun bond ini mempunyai bond dipole, kesemuanya ada bond dipole, but later we can cancel all bond dipole here menjadikan mu equals to 0. So itu maksudnya untuk statement di sini. Kesemua basic shapes with same terminal atoms, walaupun mereka mempunyai bond dipole, okay, walaupun bond itu adalah polar, tetapi all bond dipole can be cancelled with each other. So the resultant dipole moment mu will equals to 0. So they will be nonpolar molecule. But we do have some special case over here. Usually, kalau central atom ini mempunyai lone pair, Okay, usually kalau central atom mempunyai lone pair, they will be polar molecule. So exceptions untuk this molecule yang mana central atomnya mempunyai lone pair, tetapi mereka adalah non-polar. Okay, so they are untuk molekul AB2E3 dan juga AB4E2. So if you see from the molecular shapes, AB2E3 refers to linear shape, AB4E2 refers to square planar. So even though the central atom here has lone pair, tetapi this molecule will be non-polar. Sebab usually sekiranya central atom has lone pair, they will classified sebagai polar molecule. So exception untuk these two molecules. This is the example of basic molecular shapes. So as you can see from these structures, central atom has bonding pairs sahaja and no lone pairs. So walaupun all bondings here adalah polar bonding, okay, ataupun kita katakan mempunyai bond dipole, tetapi since all terminal atoms adalah sama and it is from the basic molecular shapes, so the shapes is said to be symmetrical, so this molecule will be non-polar molecule. So apabila non-polar molecule, maksudnya mu is equals to 0. Kenapa mu equals to 0 walaupun kita ada polar bonding di dalam struktur ini? Ini adalah kerana all bond dipole in this molecule can be cancelled with each other. And that will give the resultant dipole moment mu equals to 0, so molecule will be non-polar. Next will be characteristic of a polar molecule. So a molecule is a polar which is mu not equals to 0 if the molecule contains polar bond. For example, in this diatomic molecule HF, so HF adalah two different atoms with two different electronegativities value. So of course this bonding will has bond dipole. So bila bond ini adalah polar, of course the whole molecule will be polar. So hence resultant dipole moment mu not equals to 0. The second one is when we have symmetrical shape but different terminal atoms. So what is symmetrical shape? Symmetrical shape ini merujuk kepada basic shapes AB2, AB3, AB4, AB5, AB6. Tetapi with different terminal atoms. So kalau ada different terminal atoms, walaupun it is basic shapes, maka they will be classified as polar molecule. Okay, kenapa macam tu? Kerana walaupun dalam molekul CFCl3 di sini, we can draw arrow dipole untuk setiap bonding, menunjukkan bahawa all bondings here has bond dipole, tetapi all bond dipoles here cannot be cancelled with each other. Okay, kita tak boleh cancel out. Kalau cancel out boleh jadi kosong. Yang ni tak boleh cancel out. Kenapa tak boleh cancel out? This is because the electronegativity difference between CF dan Cl adalah tidak sama. So bila tak sama, we cannot simply cancel out. Cancel out tu macam kita tolak kan. Tolak A, 3 tolak dengan 3 dapat kosong for example. Okay, so tak boleh simply tolak, tak boleh cancel. Maka that will give rise to the resultant dipole moment as well. So resultant dipole moment is not equals to 0. So this molecule will be polar as well. Walaupun dia adalah basic shapes. So ingat, basic shapes tapi different terminal atoms. Okay, different terminal atoms. Yang ni berbeza. Okay, 3 ni sama. Maka they will be classified sebagai polar molecule. Yang ketiga adalah shape symmetrical, asymmetrical. Asymmetrical shape refers to central atom that has lone pairs. Okay, so kalau central atom has lone pairs ni, mereka bukanlah basic shapes. Okay, tetapi shapes yang kita ubah daripada basic shapes. Okay, seperti mana yang awak dah buat dalam molecular geometry sebelum ini. Alright, so for central atom that has lone pairs, maka kita panggil sebagai asymmetrical shape. Okay, asymmetrical shape. So dalam asymmetrical shape, for example in ammonia here, antara N dengan H, of course H is more electronegative. So anak panah akan masuk ke dalam. So in this case, this all bond dipole here, kita tak boleh cancel. Okay, we cannot cancel all bond dipole, itu yang pertama. Dan yang kedua, kita ada lone pairs di sini. So lone pairs juga akan give rise to the resultant dipole moment. Lone pair juga akan menambahkan nilai resultant dipole moment. So mu will not equals to 0. So apabila mu not equals to 0, maka this molecule will be polar. So untuk asymmetrical shape, di mana central atomnya having lone pair, usually mereka adalah polar molecule. Kerana apa? Yang pertama, because all bond dipole cannot be cancelled with each other, and also with the presence of lone pair that give rise, yang akan meningkatkan resultant dipole moment. Okay. Tetapi exception untuk AB2E3 dan juga AB4E2. Walaupun this central atom having lone pair, okay, dalam linear here dan dalam square planar here, tetapi these two molecules are non-polar molecules. Okay, so this exception kita dah bincangkan dalam characteristic of a non-polar molecule just now. Steps to identify polarity of molecule. Firstly, you need to draw Lewis structure of the molecule and then count the number of electron pairs, termasuk bonding pair and lone pair on the central atom. Next, identify electron pair geometry. This one is actually the rangka of the geometry, okay, from the basic shapes. And then identify molecular geometry of the molecule, okay, whether it is AB ataupun ABE. And then tengok sama ada the molecule has bond dipole dan adakah bond dipole can be cancelled with each other. Sekiranya bond dipole can be cancelled, maka mu equals to 0, hence it will be nonpolar molecule. Dan kalau bond dipole cannot be cancelled with each other and plus ada existence of lone pair on the central atom that give rise to the resultant dipole moment, so mu not equals to 0, the molecule will be polar molecule. So basically these are the steps yang you have to follow in order to identify polarity of molecules. So that's why it is very important for you to know on how to draw Lewis structure correctly and also to identify molecular geometry correctly before you find the polarity of the molecule. Okay, nak tahu polarity bergantung kepada dua benda ni. Okay, Lewis structure dan juga molecular geometry. So for Bef2, for example, you have to draw its Lewis structure and then later on identify the geometry of the molecule. So I dah identify yang ini sebagai AB2 and having linear shape. So ini adalah shape according to molecular geometry yang I dah lukis siap-siap. So from here antara Be dengan F, kita ada different electronegativities value between them. So you can draw the arrow dipole showing that these two bonds adalah polar. So this bond has bond dipole which is polar bonding. So bond dipole here can be cancelled with each other. Kenapa boleh cancel? Kerana this is basic shapes with same terminal atoms. So this bond dipole can simply be cancelled with each other. So resultant dipole moment mu will equals to 0. So this will be nonpolar molecule. Next is carbon dioxide. So from the Lewis structure and molecular geometry, this is AB2 which is linear shape as well. So C and O has different electronegativities value. So we can do the separation of charge and you can draw this bond dipole as well. So in this case, bond has dipole ataupun polar bond. So we have two polar bonds over here. And then this bond dipole can be cancelled with each other. Yes, they can cancel. Kenapa boleh cancel? Kerana this is basic shape and they have same terminal atoms. So all bond dipole can be cancelled with each other. That will give resultant dipole moment mu equals to 0. So this will be nonpolar molecule. The next molecule is ozone. So is ozone a nonpolar or polar molecules? So if you can see from the structure of the molecule, kita ada 3 oxygen atom. So supposedly apabila this covalent bonding dibuat melalui 2 atoms yang sama, so supposedly we cannot do separation of charge delta plus and delta minus between similar atoms. So hence you tak boleh lukis jugalah arrow of bond dipole tadi. Arrow of dipole. Tapi bagaimanakah kita nak tahu polarity of this ozone molecule? Masih ingatkah awak? Kita ada faktor yang ketiga tadi, iaitu daripada molecular shape. So daripada Lewis structure, I have identified this molecule to be AB2E, which is daripada rangka trigonal planar. Gantikan satu bonding dengan satu lone pair on this central atom. So that will give you band ataupun V-shaped. So di sini, of course, we will have no bond dipole. We will not have any bond dipole because these 2 atoms adalah symmetrical. And then kita ada lone pair on the central atom over here. So with the presence of this lone pair, this will give rise to the resultant dipole moment. So ini yang akan menyebabkan resultant dipole moment not equals to 0. So this molecule will be polar molecule. So sekali tengok, kita mungkin akan assume bahawa this molecule ini adalah non-polar. Kerana apa? Kerana tiada perbezaan elektronegativity di antara kesemua atom yang terlibat dalam bonding. Tapi jangan lupa, kena tengok pada central atom dahulu. So kalau central atom ini mempunyai lone pair, lihat pada dia punya formula of the geometry. So ada saja lone pair dekat sini, bermaksud there will be generation of the resultant dipole moment. Lone pair will give rise to the resultant dipole moment. So hence this molecule will be polar molecule. Mu not equals to 0. CCl4. So from the Lewis structure, it is identified that the molecule has AB4 geometry formula and it is refers to tetrahedral. So this is the shape of the tetrahedral. And then if we look at the bond polarity, yes, we can have bond polarity ataupun bond dipole untuk setiap bonding over here because C and Cl has difference in their electronegativities value. So CCl4 tetrahedral adalah symmetrical geometry and plus they have same terminal atoms, similar terminal atoms, and all bond dipoles exist in the molecule. All bonding has bond dipole. And this bond dipole can be cancelled with each other. Kenapa bond dipole can be cancelled with each other? Yang pertama, because tetrahedral adalah basic shapes ataupun symmetrical geometry. Dan yang kedua, disebabkan oleh having same terminal atoms. And resultant dipole moment mu equals to 0. So the molecule will be non-polar molecule. Next will be CHCl3. So for CHCl3, kita ada 1 hydrogen dan 3 chlorine over here. So do we have bond dipole in all bondings di sini? Yes, kita ada. So antara C dengan H, C is more electronegative, so anak panah masuk ke dalam ke arah C. C dengan Cl, Cl is more electronegative, so anak panah keluar ke arah Cl. So daripada geometry of the molecule, this is AB4 and the shape is tetrahedral. So adakah molecule ini polar or non-polar? So these shapes adalah geometry, tetapi we have different terminal atoms. Ada satu hydrogen dekat sini yang tak sama dengan terminal atoms yang lain. And then this molecule juga mempunyai bond dipole. So all bondings adalah polar. But all bond dipoles cannot be cancelled with each other due to different electronegativity of the terminal atoms. So seems kita ada satu CH bonding over here. So all bond dipoles here cannot be cancelled with each other. Dia tak boleh cancel out di antara satu sama lain. So this will give rise to the resultant dipole moment. Again, nilai resultant dipole moment akan bertambah, which is mu not equals to 0. So this molecule will be polar molecule. Next is ammonia NH3. So from the molecular geometry formula, it is AB3E, which is from the Ranker tetrahedral. So the geometry is trigonal pyramidal. So what we have in this NH3, kita ada of course bond dipole antara N dengan H. Okay, N is more electronegative, so hence arrow dipole akan masuk ke arah dalam, moving towards nitrogen. And not to forget, on the nitrogen as well, kita ada lone pair. So this lone pair of course akan give rise to resultant dipole moment. So this molecule, trigonal pyramidal, adalah asymmetrical geometry because we have lone pair on the central atom. So walaupun kita ada polar bonding in the molecule, tetapi all bond dipoles here cannot be cancelled with each other. And plus lone pair will give rise to resultant dipole moment. So resultant dipole moment mu is not equals to 0. Ammonia will be the polar molecule. Next is XeF2. So from the Lewis structure, we can identify this molecule to be AB2A3, which is a linear molecule. So AB2A3 kita ambil daripada rangka trigonal bipyramidal AB5. Gantikan 3 bonding pair dengan 3 lone pair, so you akan dapat linear shape. So what we have in the linear shape, so antara Xe and F of course ada difference in electronegativity's value. So the arrow of dipole akan pointing towards the fluorine. So daripada sini we can see seolah-olah we can cancel these 2 bond dipoles. And not to forget, we also have lone pair on the central atom. Ada 3 lone pairs di situ. So untuk 3 lone pairs ini, if you can see from the orientation, they are actually on on trigonal planar orientation. Okay, so according to our previous discussion, jika kita ada trigonal planar shape dan ada same terminal atoms, so maka the shape will be nonpolar. Okay, because we can cancel all the bond dipole. But now kita ada lone pair. So lone pair pun akan ada dia punya dipole yang tersendiri, but it is not a bond dipole because lone pair is not a bonding. Okay, so lone pair ada dia punya dipole yang tersendiri, and kita ada 3 dipole untuk lone pair pada kedudukan trigonal planar, dan terminalnya samalah, okay, kerana kita ada 3 lone pair kan. So we have 3 terminal lone pair. So we can also cancel the dipole of these lone pairs. Okay, so bila semuanya boleh kita cancel, okay, bond dipole kena cancel dengan bond dipole. Okay, sebab dia punya strengthnya setara bond dengan bond. Lone pair dipole must be cancelled between lone pair dipole saja. So since all dipoles can be cancelled with each other, kita takkan ada any resultant dipole moment anymore. So mu will equals to 0. So untuk XeF2, it is a symmetrical shape kerana ada lone pair on the central atom, tetapi all bond dipoles can be cancelled. Okay, bersama-sama dengan lone pair dipole tadi. Okay, pun boleh di cancel antara lone pair dipoles. So that will give us resultant dipole moment mu equals to 0. So this is nonpolar molecule. As the summary, if you have symmetrical shape or basic shapes with same terminal atoms, ataupun diatomic molecule with similar atoms, or asymmetrical shape for AB2E3 and AB4E2 sahaja, so this molecule will be classified as nonpolar molecules kerana all bond dipoles can be cancelled with each other, okay, dan memberikan resultant dipole moment mu equals to 0. But if you have symmetrical shape or basic shapes with different terminal atoms, diatomic molecule with different atoms, and asymmetrical molecule, that is central atom yang mempunyai lone pair, so in this case all bond dipole cannot be cancelled with each other, and lone pair will give rise to the resultant dipole moment, so hence mu is not equals to 0, so these molecules will be classified as polar molecules.